Hello and welcome to the fifth video of Scan DRC series. I'm Akanksha Pushkar from Tessent Technology Enablement team at Siemens EDA. In this video, we will build on our previous learning and take a deeper look at the R2 Scan DRC, focusing on how this check helps reinforce a robust and effective scan design implementation. So let's begin with the R2 violation. What is R2 violation? This rule first analyzes the connectivity between the core level scan pins and the top level ports. As part of this extraction, it considers any pipelining element and signal inversion present along the path. Once the connectivity is identified, this rule verifies whether scan shifting is correctly supported from top level ports to the scan input pins at the core boundary, and from the scan output pins at the core boundary back to the top level ports. When is R2 reported? R2 is reported when the tool transitions from setup mode to analysis mode during Scan DRC checks. Significance of R2 is to satisfy the controllability and observability from scan perspective. R2 can occur in these contexts, and it is treated as an error. Default handling for R2 cannot be downgraded to warning. Possible causes of this DRC violation are improper DFT connection during integration, improper constraint defined for TDR and test setup, missing or incorrect connectivity. The core level scan pins are not properly connected to the top level ports. This could result from incorrect port mapping or design hierarchy issues. Next, let's examine the R2 violation in more detail in context of scan retargeting and understand how it is detected and fixed. Once the initial design setup is complete, we execute the check design rule command, and this is where the R2 violation gets reported. Let's now analyze the reported R2 DRC violation step by step using Analyze DRC Violation command. Here, the EDT channel output from processor core instance processor 1 was intended to be connected to retargeting mode 1. This connection is required so that when the design operates in retargeting mode 1, scan pattern can be successfully retargeted from the processor core and the corresponding output can be observed at the chip level. However, an error was introduced during the EDT insertion stage, specifically for the signal processor core RTL2 controller EDT channel out 0. Retargeting mode 2 was mistakenly used as the enable DFT signal instead of the retargeting mode 1. As a result, the EDT channel output was not active during the intended retargeting mode, leading to an R2 violation and preventing correct scan pattern retargeting for the processor core. Now, this issue needs to be resolved during the EDT insertion step by correcting the enable DFT signal using the retargeting mode 1. Here, we can see the add DFT modal connection command is used to define how multiple core scan pins, such as EDT channel outputs, are connected to a limited set of top-level ports, for example, GPIO pins. This connection is established using modal multiplexing, where the active path depends on the selected retargeting mode. In this case, the modal connection was incorrectly configured. To address this, we correct the modal connection and update it during the EDT insertion step as shown here. This ensures that EDT channel output are enabled under the correct retargeting mode and the scan pattern retargeting at the chip level works as expected. Now, after the modification in EDT insertion step, we rerun the check design rule command, and here we can observe how the before mentioned violation is now resolved. This brings me to the end of the fifth video of the Scan DRC series. For any queries, please contact me at the email address provided. We will continue with more Scan DRCs in the upcoming video. Thank you.